Morning. Today we're going to talk about drill bits, the parts of a drill bit, how a drill bit works. But first of all, I want to talk about cutting. In order to cut, the material you're cutting with, i.e. the tool, it could be a saw, a drill, a tap, end mill, plane for wood, but whatever the tool is that you're cutting with has to be harder. That cutting edge has to be harder than what you're cutting. We'll take a hand saw or a skill saw or whatever you want, table saw, and we'll cut wood all day long. I can easily take a 2x4. I can cut teeth in the 2x4 with a hand saw. Won't look very good, but I can do it. And then I can try to saw down a telephone pole or saw another 2x4. And you notice, well, that sounds kind of stupid. Yeah, I won't say stupid, but foolish, because the material I'm using is the same material that I'm cutting with. But yet, we'll take a piece of steel and we'll cut another piece of steel with it. What is the difference? The difference is called hardenability. Steel is a rare animal that I can heat treat. If you've watched Forged in Fire, Sons of Guns, any of these shows on Discovery Channel or History Channel where they're making something and they're heat treating it, that's what they're doing. What they're literally doing is changing the grain structure in the material. They're causing chemicals to go into solution, they'll rearrange themselves, the grain structure will rearrange itself and make it more dense. Henceforth, I can take one piece of steel and heat treat it, make it hard, and cut another piece of steel with it, as long as the piece that I'm cutting is softer than what I'm cutting with. Now, hardened steel has some downside. Well, make everything hard. No, when you make something hard, you make it less flexible. So you've got an issue there. The Japanese samurai swords, if you're really to look at it, the only part of it that is extremely hard is the edge, where you want to hold that extreme keenness edge. The rest of it is like a big spring. It's softer behind the edge. So it acts like a spring or bends and allows it, and when it bends, it will not break. So there's the difference. We can do lots of things with steel. But this here, we need to have something that's harder than what we're cutting. Now, this is a standard drill bit. This is as big as they get, as far as your 2-flute twist drill, and we'll get more into that terminology later. This material it is made out of is called high-speed steel, HSS. In machining, what that means is that it's got a lot of additives in it. Additives, we're talking alloys, like a cake where you're adding chocolate chips and that's what alloys are. They're changing what's going on in the steel. We'll put tungsten in there. Tungsten's got a melting temperature of 6,000 degrees. We'll put vanadium in there. We'll put molybdenum in there. We'll put chromium in them. These are all high wear resistance, high heat alloys that we would add to it. So this makes this incredibly hard, but it makes this incredibly brittle. So this is not very flexible, but it is awful brittle, but it will cut. Now, the reason I use a drill to let you know, first of all, there's not a machine in this entire building that we work in, the MEC, where you're coming to class, that can run this. I do not have a machine in the machine shop that has enough horsepower to run this drill. This is an animal. This thing will suck up about 15 to 20 horsepower. That's a lot of oomph. But you're making an awful big hole. The part that cuts is this leading edge here. This is called the cutting lip. This is where the chip is formed. Now, if you've ever used a chisel in wood, which is kind of the same thing, where I'm going to cheat on wood even though the cutting principle is not exactly the same, it's close enough. This is a chisel. This actually will start, as this is rotating, it will start to form the chip. The chip is formed between this edge and this edge on the inside. This is what's going to do the cutting. We get to the center of the drill. Now, I was talking to 15 to 20 horsepower. Okay, if we had 20 horsepower, 19.99%, 19.99 horsepower, and that's probably way off the charts, is used by this center section. This is called the chisel point. This does not cut. This center section here literally extrudes the metal. It's like a big center punch or a cold chisel rotating it around. What it does is it squishes the metal out till it can catch on the lips, and then the lips start doing the cutting. So most of your horsepower is used up by this bad boy right here. Now notice here on your cutting edge that it falls away. It gets lower at the back, it's higher at the front. People, if this edge is lower than the back, that's a negative clearance angle. It cannot cut, because the high spot is what's going to touch, not the low spot. So you always want your cutting edge high. It needs to be the highest spot. And in the video on drill bit sharpening, I'll show you how we get this. This needs to be your highest point. It needs to fall away. Now we've got the issue of there's a fine line between too little and too much. Too much clearance, where you get a real steep, about 20-degree back angle, what we call a clearance angle on this. You'll cut like a fiend for a little bit and they'll just stop cutting because you've got nothing to support the cutting edge. Now if you get like a 2 to 3 degree, it's still falling away at 2 to 3 degree. Well, now your feed rate is going to override your clearance angle and you're still going to rub. It's going to cut, but it's going to cut hard. Now your cutting edge will last forever, but you're going to use up a tremendous amount of horsepower. People, on a drill like this would not be something you'd put in a drill press and do by hand. This thing here would rip your arm off. You got this in a machine tool, everything's clamped down, solid. Now we get down into the body of the drill. This part down here is called the body. We have inside of here what's called a web thickness. This drill is actually tapered. If you were to cut this apart, the web up here is thinner than it is down here at the bottom. It gets thicker. It looks like a cone. It's because a cone is a very rigid engineering structure. So it will hold up to a lot of force. We have the flutes. The flutes are the grooves. Anytime in my field you see grooves in something, these are automatically called flutes. This allows the chips to evacuate away from the cut. Remember, you've got to be able to clear chips. If there's no place for the chips to go, this becomes a solid piece of steel and things are going to get real ugly real quick on your drill if the chips can't clear out of it. Same for a saw. The saw, the chips have to have a place to go. They don't vaporize, they don't disappear, they just have to be able to have a place to stay until they fall out of the cut. Same thing here. These flutes also allow the cutting fluid, lubricant, generally oil but not always, to go down and cool and lubricate the cutting edge. This is going to get incredibly hot. Now, high-speed steel. The reason it gets its name in crucible steel still sells it as Red Max is that I can run this red hot all day long and it will not hurt it. This is not carbon tool steel. It will not lose its temper. But you have to be careful when you're sharpening these drill bits, because if you get it red hot and you quench it in cold water, you change the molecular structure of the steel and you make it granular. It won't hold up. It'd be like you'll be trying to cut with sand, because the grains are going to fall out. Literally, the grains are going to separate and chunks will fall off your drill as you use it. So you have to let it cool down. You don't want to grind it red hot anyway. Plus, all that heat's going to go up into your hand. It's going to get rather uncomfortable. Now there's a part around the edge of the drill, the body of the drill. It's a shiny raised part. You should see this on every drill. If you have a drill that does not have this on there, you throw that drill away. This is called the margin. This is what guides the bearing of the drill. Once the point gets in here, your biggest chattering and everything moving around is going to be when the point actually starts to enter in. Once you get down on this margin acts like a bearing. And you'll notice it's not very wide. We don't want it very wide. We've got what's called a helix, so we've got a lot of bearing area touching here. If this margin is gone, that means that you're going to be touching on this entire diameter here. Well, your frictional forces are going to go through the roof. It's going to literally weld this drill body into your piece. Well, I'm only running 100 RPMs. It will weld itself together at 100 RPMs. It doesn't take much because you've got a lot of friction going on here. Now, if a drill this size were to do that, weld itself in here, okay, this is no longer turning, it's become solid. Everything else is going to try to turn. It's welded itself into the part. Down here at the bottom is a shank. It will literally, if it welds itself in and it doesn't tear your part off the machine, it is going to twist this big chunk of steel off down here like a taffy pull. It's just going to unscrew it off. Make one heck of a noise. Everybody in the shop's going to know what happened. You're going to be diving under your beds. But anyway, that's worst case scenario. The drill sizes that you're going to be using come where? Nowhere. They don't even compare to this. You're going to be using a lot smaller, but still you can get hurt if you do things wrong. The size doesn't matter. You can still get hurt. So we've got our flutes down here leading this all out. Our chips coming in, make sure we have a good margin on it all the way. As long as we can keep fluid coming in and chips coming out, and we've got a sharp drill, you can cut and cut and cut. Now again, drills get dull. None of these tools that you have are going to stay sharp forever. The object of teaching you to sharpen drills, well, what do I need that for? How many of you in the class have already drilled a hole or going to drill a hole? I guarantee if you're going into a technical field of some kind, you're going to put a hole in something. So we need to know how to do these simple operations. There's nothing to it. It's more of a technique. I can tell you, and I'll repeat this when we sharpen the drills on the grinder, I can show you how I was taught to do it and how I do it, but it's one of those things you have to practice at and practice at and practice at. Some people will catch it real quick, some people won't. Do not get discouraged. Keep hanging in there and just keep going, because once you learn it, it's kind of like riding a bicycle. You might not do it for a while and you got to practice a little bit, but you'll catch right on to it once you start to practice it. That concludes this video on drilling.